Finding the critical region. Consider a researcher who is going to plant 25 seeds. From previous research, she knows that 80% of the seeds germinate, but she is testing a new enriched soil and thinks that this might increase the germination rate. The test statistic is going to be the number of seeds that germinate. If 80% of the seeds germinate, then 20% do not. The tables that we have cover 0.2, but not 0.8. So consider a success to be a seed not germinating. So if x is the random variable, the number of seeds that do not germinate, then it's binomial with 25 trials because we plant 25 seeds, and a probability of success of 0.2. And remember, success here is that the seeds don't germinate. Our null hypothesis would be the situation of no change. So the probability of not germinating is the same in this new enriched soil as it was in previously tested soils. If the researcher is correct and more seeds will germinate, then less will not germinate. So our hypothesis, our alternative hypothesis, has to be that the probability of a seed not germinating is less than 0.2. She decides to test at the 5% level of significance. So let's look at these cumulative tables for n equals 25 and probability of success 0.2. So this corresponds to 0.38%, 2.74%, and this is 9.82%. That's above 5%. So really, our critical region needs to be here. So you can't always, with these discrete distributions, get exactly 5%. You go as near to 5% as you can without going above. At the 5% level of significance, the critical value is 1. The critical value is the first value in the critical region. And the critical region consists of the values 0 and 1. So if all of the seeds germinate, 0 do not, or 24 seeds germinate, and that means 1 does not, we are in the critical region. If one of these were the result of the experiment, we would have reason at the 5% level, or more correctly, at the 2.74% level, known as the actual significance level, to reject the null hypothesis. So, as we've mentioned before, this is the critical region, and if we get a value in here, we would reject the null hypothesis. So if it takes a value anywhere other than in the critical region, that's known as the acceptance region, where we would accept the null hypothesis.